Here we're going to look at question 1 from section 2 of the ENGAA 2018 paper. In this question, we're told we have a man cycling along a straight horizontal road at a constant speed of 9 meters per second. We're told that he passes a boy who's cycling along the same road in the same direction at a speed of 5 meters per second. When the man draws level with the boy, we're told that the boy accelerates at a rate of 0.8 meters per second, which he maintains until eventually this boy passes our man. The question then asks us, how long does it take until the boy draws level from the point at which the man and the boy are initially level? If you would like to have a go at this question, pause now, otherwise let's have a go at it. So in this question, we're talking about constant accelerations and velocities, as well as times and, to an extent, distances. Now, is there any topic that you can think of which connects all of these topics together in a useful way? Well, what you should probably be thinking of is our SUVAT equations. What we can do is go ahead and assign each of our variables S, U, V, A and T to values we're given in the question. So, for the man, the variables for our SUVAT equations would be, well, we don't know the distance the man is going to travel before he draws level with the boy, but we do know that initially he's travelling at a speed of 9 meters per second. Since this is just a constant speed and there's no acceleration, we know that when he draws level with the boy, his final velocity is also going to be 9 meters per second. And then the acceleration is obviously going to be 0, and we don't know the time. So we've got two unknowns here. How about we go ahead and do the same for the boy then? So if we try and find out his SUVAT variables, then again we don't know the distance it's going to take to reach, for when the boy will draw level with the man again, but we do know that initially he's travelling at this velocity of 5 meters per second. We don't know his final velocity, but we do know his acceleration as well, and we don't know the time it's going to take, but this is the variable which we want to find out. Now at this point it's a little bit disheartening because actually we have three different variables here which we don't know, but we actually do sort of know the distance, because we know that it's going to be the same. When they draw level, the distance from their start point is going to have to be the same. So how about we just assign this variable d, a distance, and let's carry on with the maths and see if we can eventually eliminate d at some point. Now, to go on further, we want to try and work out an equation from one of our SUVAT equations which relates the variables which we want. So it needs to include t because this is the answer we want, and then it has to include a, u and s. It can't include v because we don't know what the final velocity of the boy is going to be. So, which equation would this be? Well, it would be this one, that s equals ut plus a half at squared. So how about we go ahead and plug in the variables which we have for our man into this equation and see what we get? Well, plugging in that s equals d, u equals 9, and a equals 0, gives us this, that d equals 9t plus a half times 0 times by our t squared. Which obviously this last term is going to just be 0, so our distance is going to be equal to 9 times the time it takes. Then we could rearrange this if we want to try and find the time that it takes for the boy to reach the man is going to be 9 over d seconds. So while this kind of final answer has a variable d in it, this is sort of expected since we did introduce a variable d, so we do have two unknowns in this equation. But if we go on and plug in the variables which we have for the boy into our equation, then hopefully we can eliminate our d. So over here I've just got the variables which we wrote down earlier, and if we plug them into our equation, then we get this. However, we still have d in this equation, but we just found out that d is equal to 9t. So if we substitute that in and simplify our final part of the equation here, then we get that 9t is equal to 5t plus 0.4 t squared. Now obviously the only unknown in this equation is t, so we can solve this and we can find the time. So by taking 9t away from both sides of the equation and factorising a t out the front, our equation becomes this, which is quite easy to solve because we can just see that for this to be true, either t has to be 0, or t has to be 4 divided by 0.4, which is just 10 seconds. So which of these is going to be the correct time? Well, obviously it's going to be our 10 seconds because t equals 0 is just the initial point when the man first came past the boy. So this time of 10 seconds corresponds to the answer B, which we're given in the question. Then, if you are interested in beyond what the question asks, we can just plug this variable of this time, of 10 seconds into our expression for d to get that the distance it takes for the boy to catch up to the man is going to be 9 times 10, which is going to be 90 metres.